Good morning. Let's start algorithm analysis. Algorithm analysis is an important topic in designing and analysis of any algorithm. After analysis of an algorithm, we can compare the performance of an algorithm. So, how can we analyze an algorithm versus designing? The predictive cost of an algorithm in terms of resource and performance is the analysis of an algorithm. An algorithm is basically the steps or set of rules to solve any problem. So, how we design that algorithm is not important, but how efficiently we are designing the algorithm is more important. So, the question is how we are designing the algorithm. So, designing algorithm on the basis of minimization of cost. So, if we are designing the algorithm, we design the algorithm in such a way that have minimum cost. So, in real time, the analysis of real time complexity of a program, we need to determine the number of each statement in it. That means the amount of time a single statement will take and its machine dependent, number of items it executed is algorithm dependent. Meaning is that the algorithm, how much time taken is depend upon machine, is not depend upon machine, but it depend upon how much time it's taking is depend upon machine. But how much time it take to execute, number of time it take to execute is algorithm dependent. So product of these two will be the total time taken by the statement. So how we compare that? We compare on the basis of frequency count. So to make analysis machine dependent, it's assumed that every instruction takes the same constant amount of time for execution, and hence the determination of time complexity of a program is the matter of summing the frequency count of all the statements. For example, if we have a loop, say I equal to 1, for loop I less than equal to 1000, and something application code and I equal to I plus 1. So how much time this algorithm will take? This algorithm will take 1000 time because it will repeat 1000 time. For example, if we have for loop for I equal to 1, I less than equal to 1000 and I plus plus, and we are saying printf percentage d I. That means we are printing I. So how much time this will loop work? This will loop work 1000 times. So how much its repetition required? Repetition are required total number of time. So that means its running time is 1000. It's taking 1000 repetitions. Same thing if we have another loop I equal to 1 and I less than equal to n and application code and I equal to I plus 2. So how much time it is running? For this code the time is proportional to n because this is depend upon n how much time it will run. It will depend upon n. Say if I'm saying again for loop for I is equal to 1, I less than equal to n, then I plus plus. So this I is depend upon print I, and so this number of repetition is depend upon this n. How much number of repetitions are there? So if there are n repetitions, that means this running time will be n. See here is algorithm loop. Algorithm loop means we have some multiply loop. For example, I equal to 1, loop is I less than n, application code and I is equal to I square. Say if I am saying for I is equal to 1, I less than equal to n and I equal to I square and print I. So how much time this will loop work? This will loop work is depend upon this I, because this I, sorry, this is not I square, this is I into 2. This I multiply by 2, this is not I square here, this is multiply actually. So if it is multiplying by 2, so it is depend upon number of multiplications required. So number of multiplications are depend upon log n, and this is basically log base 2n. Here again same, if we are dividing by 2, here we are dividing by 2, that means this is also log n. So such type of loop, here we are multiplying by 2 or dividing by 2, is known as logarithmic loop. Again, if we have some nested loop, nested means loop inside a loop. For example, if we have a loop of n number of times, and the loop inside it is j equal to 1 and j less than equal to n, and application code j equal to this. So how much time this inner loop is running? This inner loop is running logarithmic n time, and this how much time this loop is running? This loop is running n time. So here this total loop is known as nested loop and is running n log n time. Meaning is that if 1 n is equal to 1 in outer loop is also running log n time. If is 2, this is also running log n time, and say n up to n is running log n time. So add log n plus log n plus log n up to n time, log n n times, and we will get total n log n. So its running time is n log n. So if the equation is dependent quadratic equation, that means the loop is quadratic. So what will be the running time for this quadratic equation? So same here, if we are running this loop for n time here, and this quadratic loop is running, that means j less than equal to I, and this application code j equal to j plus 1, and this I equal to I plus 1. So how much time this loop is running? This loop is running depend upon this n. If here, if n is equal to 1, if n is first loop is running 1, this is also running 1 time. If it is 2, it's running 2 times. It's 3, it's running 3 times. 1 time, 2 times, 3 times. If n is equal to and so on n, it will run n times. That means the total running time of this will be 1 plus 2 plus 3 plus up to n. That means n plus 1 by 2 times. So total running time of this equation will be n plus 1 by 2, because this inner loop is depend upon this I, this I. So what is the another quadratic equation? If this is in this loop, outer loop is running n time and inner loop j is less than equal to n, that means is also running n time. So what will be the running time for this? That means if n is equal to 1, outer loop 1, it's running n time, is 2, it's also running n time, is 3, it's also running n times, n times, n times. If it's n, it's also running n times. So total running time is equal to n plus n plus n plus up to n times, and this n times. So it will be n square. So its running time is here n square. Say for example, if we are having a for loop here for I equal to 1 to I less than equal to n and I plus plus, and another loop here for j equal to 1, j less than equal to n, j plus plus, and here printf. I, comma j. So what is the running time of this? That means this is our inner loop, this is outer loop. So that means this for loop, inner for loop is running n time, this outer loop is also running n time. So its total running time is n fn is equal to n square. So suppose an important problem which is discussed in algorithm insertion sort. What will be the running time for insertion sort algorithm? This is an important program, important algorithm for sorting. So basically how this algorithm is working of this algorithm is sorting of n numbers in an array. Suppose this is an array of n numbers. This is an array of n numbers. So and its indexes start from 1 to n. Don't confuse with this. Its indexing is starting from 1 instead of 0, because an array, most probably we start array with like as if it is array, so we start with 0. Indexing is start from 0, but here indexing is start from 1, 0, 1, 2. So it's not starting from 0, 1, 2. It's starting from 1, 2, 3, and so on up to n. So how this algorithm is working? Insertion sort A is applied, insertion sort of n numbers. So it's starting from j equal to 2 to n, and do key is an element which have to be placed on in an array with aj. That means we select first and second element as the key, and then I tends to j minus 1, while I equal to greater than 0, greater than 0 and ai greater than key, then do ai plus 1 tends to ai and I tends to I minus 1, and in last ai plus 1 tends to key. For example, if we have an element in an array, say elements are here 5, 3, 9, 2. So place these elements. So how we place these elements as we're using insertion sort. So first we are starting from j equal to 2. So how we are starting from here. So first element is 2. Sorry, 5. We are not doing anything with this element. We pick this element, second element, third element is j equal to 2. J equal to 2 here, and then he's saying key tends to aj, that means a2 is key. So here key is 3. When key is 3, then is saying I tends to j minus 1, then value of I is equal to 1, and I is greater than 0, yes, it's true, and ai greater than key. Ai means a1 is greater than key, yes, 5 is greater than key. If is it true, then do ai plus 1 times to ai. That means we are doing we are replacing a2 with a1. That means we are putting this value here to we are replacing this value here and this to here. That means 5 will come from this to this place, 5 will come to this place, and this will be left, and now it will check again. The value of I will reduce to 0, and if value of 0 is value of I is 0, that means it will terminate while loop, and at this place ai plus 1 tends to key. That means at the value of a1 this will be 3, so the nav value will be 3, 5 in the array. Now the array value is 3 and 5, and same now j equal to 3, then at j equal to 3 the value will be 9, at j equal to 3, then again do the same step. So this is the insertion sort. That means we always select this element as key, and then place the position of this key in the array, and this element will be sorted. So now question is, what will be the running time for this algorithm? So we check how many time each step is running. Here each step for first step for j tends to 2 to length of a, this step run n time and say this is the cost of this element, this cost, and this is frequency. So what is the frequency? We are saying it is repeating n time and is the cost is C1. It's why it's repeating n time because it's from 2 to length of a, that means total number of element are n. Here do key tends to aj, that means every time we are taking a new element to place in this, so that's n minus 1 time and this cost we are saying cost is 0. This is an command line, so its cost frequency is 0, cost is C3. And then if I tends to j minus 1 is the next step, it's also running n minus 1 time and its cost is C4. While I greater than 0, it's when it's going to an inner loop. So when it will enter in an inner loop, it will enter in inner loop when these two values are true. So if it is true, then we are saying this tj is the function, that means summation of this time. That means what is tj? Tj is the, let tj be the number, tj be the number of times of the following while loop is treated for the value of j. So how many times it will run? So this tj is the number of repetitions for this while loop. So this is also depend on the same tj minus 1 and tj minus 1. When if it will go to inside while loop, then these both will run tj minus 1 time, and last this will run n minus 1 time. That means this key value will placed on ai plus 1th location. So we add these all to get the total cost of this algorithm. So when we add this, we get C1n plus C2n minus 1 plus 0 plus C4n minus 1 plus this plus Tj minus 1 plus C7 plus this. Now there are two cases. Was the best case of this algorithm? The best case of this algorithm is if the number are already sorted. If the number are already sorted, then it will never goes to inner loop in while loop. So what will be its cost? Its costs will be C1n plus C2n minus 1 plus C4n minus 1 plus C5n minus 1 plus C8n minus 1. That means it will never goes to this loop C5, this C6 and C7. This will never goes to these two steps in best case. So add these total all. When after adding these, we will get an equation something like that: a n plus b for constant a and b that depend upon the statement cost of ci. For example, when we add these all, so we get c1, we make this common n, c1 plus c2 plus c4 plus c5 plus c8 minus c2 plus c4 plus c5 plus c8. So here this is an equation with constant, this is the constant. So we can say this is the linear equation. Linear equation will become like an. So this is a, this is a, and plus b. So this whole is b. So this whole is b with negative mark. This whole is b. So this is what saying this is the linear equation, linear function. So what will be the running time for linear function? We represent the running time of linear function, or say if it's order of an plus b, so we say this is equal to order of n. That means the total running time of this equation in best case will be order of n. But if it is worst case, then both while loop and for loop will work. Then means when it will goes to while loop, then it will run j equal to 2 to n j. That means this inner loop will work, and inner loop will work n plus 1 by 2 minus 1, and j1 j equal to 2 to n, j minus 1 equal to n plus 1 by 2n. Then when we add these all, so we get c1n plus c2n minus 1 plus c4n minus 1 plus c5n plus 1 by 2 minus 1 plus c6 this plus c7 plus c8. That means we will add these all constants. So we will get this n square plus this n plus the minus this. So now this is forming an quadratic equation. That means a n square plus bn plus c for some constant a, b and c. So if the equation is quadratic equation, so we can represent a n square plus bn plus c. So its running time will become order of n square. That means for any quadratic equation, its running time is always order of n square. So was in binary search, same example if we are considering binary search. So what will be in the binary search? We know in binary search we always find middle element. Suppose we want to search here 9 in an array. So how we find 9 in an array? So we first find middle element. So how we find middle element? We find lower bound plus upper bound by 2. So here lower bound is 1, 2, 3, 4, 5, 6, 7, 8. 1 plus 8 by 2. So this is the middle element. So we find mid here like that. Mid equal to lower bound plus upper bound equal to by 2. Now if this element is less than 9, then we find in right hand side and we change its lower bound. If it is element search to be searched is less than 7, so we search in left hand side of this. So now 9 is greater than this, so we goes here and again find the middle element. Now middle element is this. If middle element is this and compare with 9, if 9 is less than this, then we find here and we got here 9 is mid and then element found. So what will be its running time? Its running time is again depend upon the cases. In best case, so what will be the best case of this? Best case of this is the middle element is first middle element here. This is the search element. Then this will be best case. That means first element is the middle element and that element is to be searched. Then its running time will be order of 1. We are getting the element in order of 1 time. If in worst case it will be log base to n plus 1 step and it will be order of log n. That means the running time of binary search in worst case and average case is always order of log n time. That means it takes order of log n element. Suppose the total number of element are 8. Total element in an array elements in an array are 8, then searching is order of log base to 8, that means equal to 3. That means it will take 3 uh, running time to compute or to find the element which is to be searched. If it find in 3 steps, it is there, then it will find in 3 steps, otherwise the element does not exist in an array. Thank you.